and I did my bachelor's and master's from IISER Bhopal, and I did my master's thesis in at IISc, and the project topic was black hole information paradox, and it was done under Dr. Chetan Krishnan. So he's a string theorist, and I'll answer and discuss more about me through questions. So yeah, the floor is open for questions. Go on.
Yes, Amay, you can unmute yourself and.
So Madhur Bhaiya, I had a very weird and simple question. So it's like the curriculum in IISER Bhopal or any educational institute in India, especially, is kind of restricted. So we have a very limited number of courses, and so the things we learn are they means are they sufficient to get into the modern day research field, or should we pursue like another MS degree? So like anything of that sort, like should we spend more time in doing more coursework rather than directly entering into a PhD or something, uh, any other higher education?
See, so the coursework and the curriculum that has been made and that has been given to us at IISER Bhopal in Department of Physics and Mathematics that I've seen is to build our concepts and to build a fundamental strong. So to enter is in any particular research field, you have to do internships and do an MS project after that. And for like when you start your PhD, you don't have to relearn those basic concepts. So understanding and doing your coursework is very good. That is what I understand. And to get the idea of what research and other things are going on in the contemporary world, like you should like attend meets in physics club and go for internships, talk to people, talk to your teachers, what they are doing, get their guidance, but you should focus on your curriculum. That is very important, because if the fundamentals are not strong, you'll not be able to understand the papers online that you get. And you can follow one field in physics and just keep on reading the papers online on archive or somewhere, or any particular journal, but you should follow your coursework very thoroughly and understand everything, like solve more questions. And all the courses that are listed in physics and mathematics, they are like good enough to enter into any research after your fourth year. So have I answered your question?
Okay, thank you. Yeah, yeah. Thank you.
Sure. Yeah.
Okay, so next we have a question by Ashwin. Yeah, Ashwin, you can go ahead and unmute yourself.
Thank you. Madhur Bhaiya, can you please tell us briefly about what about your MS thesis? I mean, what research you helped conduct in IISc?
Okay, so my work, as I just told, it was on black hole information paradox. So, like explaining what the black hole information paradox, I don't think so that would be the scope of this talk right now. I'll explain what I did was like I was trying to understand the black hole information paradox in flat space, in the space that we live in. That is not correct when I say that in the space when we live in, because it's a cosmological space and the space is evolving and accelerating. So, but my work was how to understand the black hole information paradox in flat space. So the thing is, recent developments has shown that black hole information paradox can be solved in positively curved spacetimes. But there is no sign of understanding the black hole information paradox in flat space, means with zero curvature. And our universe has almost zero curvature. It has a slightly positive curvature. So but like neglecting that and understanding those as perturbations, we if we tend to resolve the paradox in flat space, it would be a good resolution and the problem would be solved. So my work was in that direction, and we were trying to develop a method as a resolution towards the black hole information paradox in flat space.
Thank you, Via.
Okay, so next is Anuja. Anuja, you can unmute yourself and ask the question.
Hello, Madhur Bhaiya. So my
Hi.
question was कि how according to you how does string theory has capability to answer some questions that other modern or previous theories don't?
Okay. So this is a very I didn't I, this is a very vague question to like capability, like understanding the capability. See, string theory, the development of string theory started in 1970s and 80s, and they were trying to understand what, like how can a theory, like how to explain hadron collisions in general, and how to explain hadron physics. And strings were developed, and when you have a particle, you take a particle and you do relativistic mechanics and dynamics on it, you get some equations and you get some things. And people were like, "Okay, when we have a zero dimensional particle, we can extend it to one dimension things," and they were strings. And they developed it to understand the gluons and the quark gluon plasma and all those things, but they could not explain it very well. But during the process of understanding string theory, what they found is they automatically get a spin 2 boson, also known as a graviton, that you learn eventually, and you automatically get gravity in string theory. You don't have to add any other thing by hand. So that was like, even though it could not explain strong nuclear forces at that time, string theory was not left alone, and people were like, if you want to quantize gravity, I'm sorry, quantize gravity, and string theory would be a viable candidate, because string theory is already based on quantum mechanical principles, and it is already on relativity. So you already have quantum mechanics in general, quantum field theory, and automatically, if you get a graviton in it, it will be a candidate of a grand unified theory. So in that sense, string theory is a good candidate. But the problem it brings us is the higher number of dimensions, the compact dimensions, the higher dimensions that you cannot see. And because, see, for example, I'll give you a trivia that the colliders that we have right now have energy of around 10 to the power 3 GeV. To understand and to not to understand, but to see the compact dimensions, the higher dimensions, we have to build a collider that is capable of energy 10 to the power 19 GeV. So there's of order of 10 to the power 16. So if you want to build that kind of a collider with the physics, with the technology that we have right now, you'll have to make a collider as big as the universe. So to see those dimensions, it is not feasible right now. So that is why people are like kind of against string theory. I myself was against string theory, like when I had a naive idea of physics and mathematics. But right now, what I feel is it is a good candidate to unlocking the unified field theory, or the grand unified theory that can quantify and give us a theory of everything. So in that sense, yes, string theory is a good candidate. Now coming to your second question, there are other candidates as well. For example, loop quantum gravity. So rather than going for strings or quantizing particles, and so physics works in two parts. So you have a background is the space time, and you have the foreground is the matter and the energy thing. So space time, or the background, gives you gravity. So rather than quantizing gravity, string theory works on the particles and those things, and automatically gravity comes. And on the other side, loop quantum gravity does is it quantizes the background. It tries to quantize and find quantum particles of space and time itself. So that's a different approach to go forward. But the thing is, it is very complicated. Like, it goes for both of them, but string theory is already based on quantum mechanics, so people have more hopes for it rather than loop quantum gravity or loop quantum cosmology. And many of the physicists say that loop quantum gravity and string theory probably might be the two sides of a same coin. So there are hopes for that. So like any discussion on string theory can keep on going. So like, did I answer your question, or do you want some more clarifications?
No, thanks.
Sure.
We keep hearing things about things theory. I wasn't aware of the technicalities, so that clear.
Yeah,
Thank you.
like properly, I have started string theory just in like last 1 month. So I was using string theory, but I did not like fundamentally start it from axiom. I am doing it right now, so I have a lot more things. So you can like post your question or text me whenever you want, and you send me questions.
Okay, thank you.
Sure.
And so the next question is by Adarsh. Adarsh, you can go ahead and unmute yourself.
Yeah. Hello, Bhaiya. I wanted to
Hello.
ask that whatever you have done up till now on the black hole information paradox, what are you planning to do further in this regarding this research?
Mm. Okay. So the project that I was doing was in flat space holography, or the flat space with zero curvature, the universe with zero curvature. So there I was using something called as the ADS CFT correspondence. So you can search about it. You can write it down. ADS CFT correspondence. So that is something called as the holography. So I was using that, but I was not directly using string theory. What I plan to do in my PhD is I plan to work with Dr. Sameer Mathur, and he uses string theory directly. He uses strings to construct fuzzballs or black holes, and he calls them fuzzballs because black holes are not that black, according to him, and they are not at all black holes as the conventional black holes. So what he is using is he's imagine of strings as rubber bands. Okay, so now you takes a lot of rubber bands and uh, join them and fold them into a ball. Like you create a ball of those rubber bands, and each rubber band is represented by a string in the correspondence in physics. That ball that you get of the rubber ball is a black hole, as told by Sameer Mathur. So that is called the fuzzball paradigm. So he says using strings you can generate black holes, and if there is a fuzzball, and a fuzzball has no horizon. So if it does not have a horizon and there are states in the black hole in the fuzzball, there will be no information paradox. So it automatically resolves the information paradox if you prove the fuzzball hypothesis. So I am interested in that, and I would be working with Dr. Sameer Mathur if I get a chance to work with him, and I'd be working in the fuzzball paradigm. So using string theory, I'll be trying to resolve the black hole information paradox.
Yeah, Bhaiya, one more thing I wanted to ask that have you found any limitation upon the size of the first ball? That is the strings or the rubber bands that you have been using to make that first ball.
Mhm.
Any size limitation? Cause
No,
there's a
no, no,
term.
no. So the size limitation is not a good question, because string theory starts with something called as a fundamental length, a length scale, that is the
Yes,
Planck
yes.
scale. Yeah. So there is, see, in a theory, when you start a theory, you have to add something as an axiom. For example, you'll have to define mass. You'll not question what is mass. You'll have to define charge. You'll not question what is charge. So there, like in the conventional classical theories that I'm talking about. Similarly, in string theory, you define something as a string length, and you call it as the fundamental thing. You'll have to use experiments to define that string length, but you'll use LP you'll have to use the experiments to find the value of the string length, but you'll have to define it, and that will be defined, and everything would be in orders of that string length. So finding limitations on that length is not a good correct question. If you think and if you believe in string theory, everything would be made of strings, so there are no size limitations, because if everything is made of strings, so the whole universe is made of strings, so there are no size limitations. It becomes very obvious.
Yes, Bhaiya, thank you.
Sure.
Okay, so the next question is by Swagata Malik. You can go ahead and unmute yourself.
Hello, Maya. I
Hello.
am not a BSMS student, so I want to know
Okay.
something which I don't know about the MS thesis that everyone has to do. So
Okay.
my question goes like, how did you land up doing your MS thesis in a different institute, IISc? Because
Okay.
how did it happen?
So the thing is, first of all, there are some mandatory. So is your question complete? Should I answer?
Yeah,
Yeah. So first of all, could you please mute yourself?
yeah, sure, sure.
Yeah. So first of all, you have to just complete all the optionals, all the optional electives, all the mandatory coursework that you have of your 5-year program in 4 years, so that your fifth year has no other courses that you have to complete, including IPR. Okay. So at the fifth year, the start of the fifth year, you can talk to your professor. You will be assigned a guide at the Indian Institute of like IISER Bhopal, and you can talk to him or her, and you can ask that if is it possible for me to go out, and if the academic affairs allows you to go out, and that is only when you have completed all your coursework, and they will allow, they don't have any problem. And it depends on department by it depends from departments to it varies from department to department. So I can tell you about the physics department. I don't think so that's there's a provision in mathematics department right now, but they are planning to do that. So I don't know about the other departments, I'm sorry. So in the physics department, talking about the physics department, so when you've completed all the courseworks, you just have to email a professor outside your campus and tell him or her that you would like to work with him for as a MS student. So, and after that, you can converse with him or her to about your funding and your stay at the host institute that is hosting you, and it can be either in India or abroad. It all depends on like with whom you contact, and and if everything works out, like if you've done your coursework and if the professor outside is willing to accept you, then you can just go. There's nothing more you have to do. You just have to like get some signatures, and you can, and that guidance you can get from your departmental advisor that you are assigned at the start of the fifth year.
Okay. Okay. One
Yeah.
more question I have. That is, can you tell me about the prospects of quantum information theory, and is it somewhat related to the things that you are working upon now?
Uh, yeah. So the thing is, yes, it is related to the things I'm working on, because in black hole information paradox, that information part is related to and it comes from quantum information theory. We study the entanglement entropy. But the thing is, I am using just some basic definitions of information, and the actual thing that I work on is not the abstract concepts or the understanding of information itself. So I would like send you some people's uh, number and email ID. You can talk to them. There is someone in my batch, Swadeepan Nanda. Yeah, you can talk to him. He works directly in quantum information theory, so he would be better for your as a guide to you.
Okay, thank you. Thank you very much.
Sure.
Uh, all right. So next up is Gaurav. Gaurav, you can go ahead and unmute yourself.
Hello, Vaya.
Hi.
So can you please elaborate on the roadmap you followed, like from entering into ISL to your MS thesis, and like at what time you decided that what will be your MS thesis?
So okay. So at the end of first year, like first year, I'll just tell you about the like you know the coursework, all those things. I'll just tell you about my winter and summer internships, and then directly to the MS thesis. So and first year winter internship, nothing. First year summer internship, at the end of first year summer internship, I did nothing. And second year December, I did nothing. No, probably I did something. Yeah, yeah, I worked with Surjit Saha. Yeah, Dr. Surjit Saha, and in his Raman spectroscopy lab in December. And then second year, I went to Japan. It was the University of Tokyo Research Internship Program, U-Trip. So I worked with Professor Shuji Hasegawa on topological insulators. So the thing is, I was very clear that I want to go to theory. Like that was even before I came to ISAP. So I didn't want to miss out on experiments. So I did internships in experiment as well. That is what I did. So second year, I deliberately apply in experimental physics in topological insulators, because that was the hype and that was the zeitgeist of that time. So and 2016 there was a Nobel Prize in topological insulators, so I was very fascinated about that. So I applied for topological insulators, and there I went to Japan and did a internship on bismuth antimony telluride and understanding the properties and the topological properties of their that material. So that was purely experimental. I worked on machines and did surface physics and all those things. Then then I started third year and did my majors in physics. And December, what did I do in December? I did not do anything again. And like when I'm saying I did not do anything, that means I did not go for an internship. Yeah. So, and in third year end, I went to Germany. That was under the DARD wise internship. And there I did a computational physics work. So that was on, there's something called as Ice Cube, if you've heard of it. So that is the largest neutrino observatory at the South Pole, and they were developing some time efficiency modules. I can elaborate on that, but that's not the scope. So let's not go into that. But we were developing some modules that could kind of detect neutrinos. And for that, they needed some computer algorithms and some work and to find the correct timing efficiency of the modules. So I worked in that. So I had two internships, and one was in experimental and the other one was in computational. So I got the basic idea, and I was like, yes, I am pretty sure I don't want to go into these things. So at the end of third year and fourth year started, so I took all the theory courses in physics, all the theory courses. So that was in GR, quantum field theory, condensed matter. I did all the in cosmology. I did all the quantum the theoretical courses. I left quantum information theory that because I was not interested in that, and probably I could not take that many courses. I don't know. I don't remember. Uh, at the end of fifth year, at the end of fourth year, I started my work with Dr. Suvankar Datta. He's a string theorist, and we were like studying something called as ADS-CFT correspondence, as just I mentioned. And after that, I was told that it is good for an IISER Bhopal candidate to go out and do his master's thesis because it reflects good in your CV, and it gives you a better chance for landing up at a PhD at a esteemed institution. So then I decided, okay, I'll be going out, and then I searched for all the string theorists. And because I was interested in theory in every part of theory, so I did not fix my black hole information paradox, this kind of problem that I will do in this. I emailed everybody, and then whoever replied, I talked to my professor, Suvankar Datta, and then I decided I'll go to Dr. Chetan Krishnan at ISC, and then I went for my master's thesis, and here I am. So Gaurav.
Okay, thank you. Thank you.
Sure.
All right. That was inspiring. And next up is
That
Shashank.
was random. Many of the things were random.
But I guess yes, it does help to explore everything before you know what you like.
Yeah.
So anyway,
Yes.
we'll move on to the next question. Shashank, you can go ahead and unmute yourself.
भैया so what if like in your case you were damn sure कि जो करना है physics में करना है, so what if someone is inclined towards other subjects as well and has taken major in some other subject like say economics and mathematics, and then he is like, okay, now I think I want to work in physics as well, so how can both the things go simultaneously, and what are its scope at ICER be?
See, dekho, like the thing is like, if I want to tell you about physics, there are many other things. There are many interdisciplinary researches that are going on. People from physics go into other departments. Like, as I told you earlier, like there was my senior who worked on, who worked on stock markets and shares using quantum mechanics. So there was one of them. And there are people like I had my senior, and she was in mathematics and she worked in biology. So she used topological data analysis to understand the protein folding. So there are things like that. But to be honest, like I am not very aware of every field. So I would recommend you to talk to a career counselor genuinely and get an idea of that. And apart from that, from like as far as the courses at IISER Bhopal is concerned, like I don't know the curriculum that has changed after me. So the courses that you guys take is and the curriculum that you follow is very different from us. So I'm not be able to guide you in that respect. If you have some specific physics question, I'll be able to help you.
Okay, thank you, Priya.
Yeah.
Okay. So next question is by Darren. Darren, if you can unmute yourself.
So, hello, Madhur
Hello.
Bhaiya. My question was, which all mathematical courses in third year and fourth year will help us in like making a career in theoretical physics or doing something in theoretical physics
Okay.
from your view?
Okay. So it depends on what part of theoretical physics do you want to go. So,
Like
can you give me an
cosmology
idea?
and
Okay.
cosmology.
Cosmology. Yeah. So I think there is Parth over here. It would be better if you talk to him directly. Parth, could you answer this question for him? So he works in astrophysics and cosmology. He has a better understanding of that. So he can tell you, and then I'll answer if I feel that there are some other points that we should mention. Parth, are you here? Yeah, go on. Hello. Parth, you're not audible. Okay, so Darren, I think there's some problem in. Okay, so as far as I am concerned, so is he online? Is he audible? No. Okay, cool. So the thing is, in theoretical physics and cosmology, you will have to understand general relativity, classical general relativity very well. To understand that, you will have to understand topology, differential geometry, differential equations, partial differential equations, and some courses on. I think there are courses on what do we call that? Um, there is some advanced differential geometry, algebraic topology, and all those things. So yeah, so there are things in mathematics. If anything that is related to general relativity, if you can understand that well in cosmology, it would be helpful. Apart from that, in cosmology, even if it is theoretical, you have a lot of data to understand. So it would be helpful if you take some computational courses as well.
Okay, thank you, Bhaiya.
Sure.
Okay. So the next question is by Kavin. Kavin, you can go ahead and unmute yourself.
हेलो आपका
Hi.
बिग फैन फ्रॉम बेंगलुरु आई
अरे
हैव
बस कर यार.
I have two questions actually.
Go on.
So one is regarding the something which I have noticed a lot in my first 2 years is that I attend a set of talks or something, and sometimes it just goes a bit too overhead, bit too technical sometimes. So has that sometimes demotivated you if you have attended talks like that, or has that encouraged you more to go further into physics?
So then, like, why do you want to get that answer?
It is just that I also know that how others feel and how someone more experienced feels about it.
Okay, okay, yeah, yeah. There are instances. There are instances like probably there are like almost every time that happens that we don't know anything. Like we attend many conferences online, and I'm like, oh yeah, kuch nahi aata. And but that does motivate me more. So I come back, and after that the conference, I just mark or note down those things that I did not understand, and go back and solve questions. So on stuff related to that, for example, I attend a cosmology conference, and I did not understand, let's say, something as gravitational waves. So what I'll do is come back and just pick up the standard textbooks, for example, Scott Doodleson or Weinberg on gravitation and cosmology, and go to that chapter of gravitational waves and understand that. And if I don't understand that chapter, I'll just go back to 3 4 chapters, read that, and solve questions. So the thing is, if you solve questions, the more you solve questions, you get a better understanding. And after solving question, after I go back to the conference, and like if there are recorded videos, and try to understand things. If still I cannot understand, I just write an email to the person who wrote that or who was speaking.
Okay.
रही
And
बात मोटिवेशन की, आई एम रियली सॉरी बट आई एम सुपर मोटिवेटेड, दैट एवरीबody knows, so I can't say कि मैं demotivate हुआ कभी.
okay. And the second question is kind of related to uh, how it was before the physics major versus the end of fifth year. Like at the end of second year, maybe you would have had a thought of how a physics major would be, like a picture, and then at the end of fifth year. So was there any different thing which you didn't expect or something like that?
To be honest, I did not have any thoughts like कि physics major कैसा होगा.
Okay.
So I just went for it because I wanted to learn everything in physics. I tried doing that. I could not. I know that. I am still working on it. I am trying to understand things. And moreover, I'm more focused on fundamental issues. So I'm working on one of those. I'm happy to do that.
Okay.
And Parth has written the answer for Darren. Darren, please read that answer in the chat box.
Yeah. Thank you.
Sure.
Okay. So there are no more questions in the chat box.
Great.
So maybe till anyone has a question, I'll present one of my questions if that's okay.
Whoa. No, it's not okay.
Okay, then Aditya Raja has a question then. We can,
नहीं, go on यार, go on. हो जाए.
uh, yeah. So my question was that what is your current work based on? Like how did you get into Cambridge and yeah, both of these things.
So Cambridge is a master's degree that I applied for. So at Cambridge, if you want to do a PhD in theoretical physics or mathematics, so you have to get a part 3 because that is kind of a prerequisite. They don't mention it, but the professor cites that like if you want to apply for a PhD and you look at the guides and their websites do mention that for an um, for coming into their group, you should do a part 3. So that is the part 3 tripos also, and so that is offered by the Department of Applied Mathematics and Theoretical Physics, DAMT. DAMT. So the thing is, I applied for that and I got selected for that. And that is a 9-month program. And after that, you have something called as the physics test. And if you pass in that, and if you pass in the interview, you get into a PhD, a 3-year PhD at Cambridge. So I applied for that, but the problem is due to COVID, I think I will not be able to go to Cambridge. Okay, coming back to Ohio. So I got into Ohio as well. So there I applied for Dr. Sameer Mathur, as I mentioned earlier. So he's already working. He's one of the big shots in black hole information paradox. So you can like search on him online, Sameer Mathur. And so I applied for him, and fortunately I got into Ohio State, and I had a talk with him like days before, and he mentioned about his work and he asked some questions. So the thing is, I got interested in black hole information paradox during my master's thesis. I was interested in a lot of things. To be honest, when I was there at ISA Bhopal, I did not go to ISC. I was doing 2 projects simultaneously. I was working with Dr. Suhas Gangadharaya on something called as, how do I explain that? Okay, it was some symmetry in 2D surfaces. So I was interested in I am still interested in theoretical condensed matter. So, and I was also working, he was my official guide. So Ankar Datta, I was working with him as well. And I was working on ADFCFT. So he was trying to understand Young's diagrams through ADFCFT. So that comes in a part of matrix models. That is also in string theory, a part of string theory. So they are called the zero-dimensional quantum field theories, as I mentioned to Sarvesh if he's here. So 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 the thing is, I was not very sure which field I choose in theoretical physics. It should be something related to math. I should be able to do a lot of pen and paper work. That is what I wanted. So I explored many things, and I'm like a master's ke liye, if I was doing this, so I applied to Sameer Mathur, and I do really like his work. I like his talks. I like the way he thinks. So I think it would be a good way to go for. I don't remember if that is the question that you asked. Like, have I answered your question, Chirag?
Yeah, actually, you answered it in
Yeah.
your first part itself, but yeah, it's
Okay. Sorry.
yeah.
रोकना था ना फिर.
No, it is good to know anyway. Uh,
Sure, sure, sure.
which actually brings me to like how important are these competitive exams that you mentioned, and like
They are very important. If
okay,
you're talking about the GREs,
yes,
the
yes,
standardized tests, yeah, they are very important. So GRE Physics, TOEFL, these three exams that you have to give if you want to land up at a, if you want to get a PhD outside in India, they are very important. In UK, my GRE scores were not asked, just the TOEFL scores were asked. But in the US, GRE scores are asked, as well as TOEFL or IELTS, whatever you wish to give.
okay. And how long did you prepare for these exams? Like,
I did not prepare that much. Like I followed a blog. So there was a lady, as far as I remember, her name is Shreya, and she scored 330 out of 340 in GRE, English general. So I just followed whatever she said, and probably within a month I prepared and just followed blindly whatever she was saying, and I gave the exam. Simple.
okay, yeah, I asked this question specifically because I guess most of us have a bad PTSD. Uh, or maybe.
PTSD.
Yeah, I mean that.
PTSD कैसे कैसे वो how is it a post traumatic stress
भैया
disorder?
आप बहुत जल्दी निकल गए. The system has been, the competition has been growing exponentially. But
अच्छा,
yeah,
हमारे तो है ही नहीं कंपटीशन ना बिल्कुल.
अरे okay. Anyway, we'll move on
No
to
problem.
Oja ji ka question. Aditya bhaiya, if you are here, please go ahead and unmute yourself.
Oh, okay, thanks. My question is pros and cons of doing MS before PhD. Like, is it preferable or not? If yes, why? If no, why?
Okay, so pros and cons of doing an MS before a PhD, is that the question?
Ah, yeah.
An MS at our institute or any other MS, like
No,
apart from,
not at our institute.
like I did not an MS project outside or an MS degree altogether after completing your masters? What is the question?
A degree altogether after completing masters before doing a PhD.
See, it depends. If you are going into the UK where there is a PhD, the PhD is of 3 years, I would recommend do an MS again. But if you are going, like it depends on what part of your field are you looking at. So I can tell you about theoretical physics. Parth can tell you about computational, and there are people here then who can tell you about their respective fields. But the thing is, like MS at ISRB was good, I agree, but I don't think so. We practiced and a lot, like we practiced so many questions that are helpful for us to get a better understanding of concepts, fundamental concepts. So if you go for a PhD, which is a 3 year long program, and that would be very intensive for you because you'll just go there and start working on some specific topic. And if you don't understand the concepts beforehand, it would be very tough. But if you go for a PhD at the US, in the US, so there the PhD program is for 5 years, and you have to take courses irrespective you come with a master's or a bachelor's. So doing a master's again for going to the US is not good. So you should directly go for a PhD. If you do a master's at IISER Bhopal, you can directly start your PhD at some institute in the US, and you will be studying courses. But in general, like directly going after bachelor's is not advisable. I would not advise if you're looking for going into some fundamental fields like theoretical physics or even in computational or like experimental. I would not mind if you directly go after bachelor's to a PhD because you'll be doing courses, and I think that answers your question.
Yeah, and one more question. How do PhD interviews go? Like, what to expect in a PhD interview?
I have not been in a PhD interview, so I can't say that.
Okay, okay.
So that was
Thanks.
very the talk I had with Samir Mathur was very informal. So that was more. I didn't, like he asked me a lot of questions, but I don't think so. It was an official interview. So I don't think so. I can't tell you.
Thanks, thanks.
Okay. So the next question is by Preetham. Preetham, if you can go ahead and unmute yourself.
Hi there.
Yeah.
My question is a bit wide. Actually, you said that you have done
Uh,
two tips
I'm
in.
sorry, but I can't hear you.
Hello, can you hear me?
Yes, now. Yeah, it's okay. Go on.
Where you said that you have done two internships, one in experimental physics and one in computational physics, and then you suddenly decide to completely switch to theoretical physics. So, what
Okay.
actually made you to think to completely switch into theoretical physics, not pursuing further in experimental or computational physics?
See, I was already decided that I would like to go to theoretical physics. I just wanted to get a flavor of the other fields. That is why I did not. It was not something that I did not like at experimental or I did not like at a computational. It was like I was more inclined towards in theoretical and some. It was like uh, nothing exacerbated my decision, but it was like it helped me decide that yes, theoretical is better. I am not saying it is experimental is not good. Obviously we need experiments, and it's not, I'm not at all saying computational is not good. We need a lot of data. Everything has its own pros and cons. It was just that I liked physics and I liked doing paper and math, pen and paper work more, so I could get that more in theoretical physics.
Okay, well.
Sure.
Okay, so the next question is by Shashank. Shashank, you can go ahead and unmute yourself.
So, Bhaiya, you just mentioned that in order to get into Cambridge PhD, you'll have to, matlab it is recommended that you do a MS again after graduating from ISER Bhopal.
Yeah,
So,
Cambridge theoretical physics and applied mathematics. Yes, it depends
yes,
on the field that you are going for. If you want to
yes.
go there for experimental and computational physics, I don't think so. It's mandatory. You can directly apply for a PhD.
So I've got two questions. Like for computation and experimental, can we follow the same system like going there and doing a master's again?
I am not sure. I think there are other people over here. Like you can ask about this to Parth. I think that
Okay,
would be good.
and
Yeah, go on.
since it is recommended that we should do a MS again after going to Cambridge, so is it
It is
feasible to?
mandatory. It's not
Okay,
recommended.
okay.
Yeah.
Since it's mandatory, so
Hmm.
so can we just go there after a bachelor's degree?
Yeah, it you can.
I
But
mean,
the cell,
doing a
but the thing, yeah, we're doing a BS exit. You're saying that,
yeah,
right?
yeah,
Yeah, but the thing is, like, let's say you do a bachelor's, you take a BS exit, and then apply to Cambridge. But the thing is, if you apply to other places, you will be competing with you, and in any other place, even Cambridge, you will be competing with people who have already have a master's. One. So, and IISA Bhopal, as of yet, it is not a very big institution. It is developing, it is growing, but it is not that recognized as compared to others. So going with a master's to Cambridge is like going with a bachelor's to Cambridge. For example, if you get selected, if you do not get selected, where do you go? If you have a master's, if you do not get selected to Cambridge, at least you can go for a PhD. But with
yeah.
a bachelor's, PhD would be tough directly.
Okay. I mean, it is possible but not feasible, right?
Yeah, it is possible, but not advisable. It is feasible
Okay.
as well, but not
Okay.
advisable.
Okay.
Yeah,
Thank you.
sure.
Okay. Next up, Swagata Malik has a question. So yeah.
So you mentioned that in UK they ask for the 12 scores, and in America,
TOEFL exam score. Yeah.
yeah,
Hmm.
and GRE is required for US. So what
Hmm.
about the other countries in Europe? What
So,
exams actually?
to be honest, I was very focused in to go to the US, and somebody suggested me to apply to the Cambridge, and that is why I applied for the Cambridge. And I did not apply to any other university in Europe. So I'll not be able to tell you about that. But what I feel, I have heard from my friends, GRE scores are not that mandatory or not even required at places and in and universities in Europe. But GRE scores are very like they're mandatory at universities in the US. So for Europe, I think you'll be. It is okay if you just give an English test. It could be IELTS or TOEFL, and you can contact your PhD advisor, and then you're good to go.
Okay.
Yeah, Parth could elaborate. He's going for a PhD in an at an European university, so you can talk to him. He's there. He'll answer in the chat. Yeah.
Okay. So next question is by Devang. Devang, if you can unmute yourself.
Okay. Read more theory or do more problems. What method help you in understanding difficult concepts? So, okay, first of all, I would recommend everybody, if they are interested in physics, to read some. There's a blog by Gerard Hooft, as it is named as How to Be a Good Theoretical Physicist. If you want to understand, like he says it for theoretical physics, but it is like more or less for everything in physics. So you could read that blog, one. And so his question is, if everybody can read that in chat. So, and do more theory or do more problems. What's his name? Okay, so the thing is, read more theory or do more problems. So it's Gerard Hooft. Gerard Hooft. He got a Nobel Prize in quantum, I think, chromodynamics. I think he worked in holography as well. So read more theory or do more problems. Everything is important. Like if you do more problems without reading the theory, I don't think so that you can solve problems. But if you just read the theory and you don't do problems, you will not understand the theory. If you don't do derivations, you will not understand the theory. So what methods help you? Like understanding difficult concepts, see, I rely more on watching videos and watching lectures rather than reading stuff and reading books. I'm not an avid reader. I have become a good reader right now after my friend Abhijit suggesting me to read books. So I did not read books that much, but I learned things you watching videos and learning stuff from lectures. I hope that answers your question, Devang. Sure.
Okay. Sorry, Devang, I missed your chat earlier. Uh, okay. Anyway, there's another question from my side. Um, so, yeah, about you mentioning about physics. So, how has your view of physics changed from like in the school Madhur Bhaiya to college fifth year Madhur Bhaiya now?
More or less, it has remained the same. Okay. So the thing is like view of physics. Like I still consider physics to be the ultimate science. Okay, I consider it to be the fundamental of all sciences. You understand. You need to like understand physics to get a better understanding of nature itself. And I had that view probably from my 11th, ninth or 10th, and so more or less it has remained the same. But the thing that has changed is I was more interested in glamorous physics in 11th, 12th. I was interested in black holes, making time machines, and all those things, big fancy stuff, and science fiction stuff. And people were, and I also, I was one of them. I did not understand the importance of mathematics that much, that comes and that lies behind physics. So I understood that while solving question and understanding how things were developed, I tried to look at physics in a chronological manner and try to visualize what was, for example, if I want to study how Heisenberg and Dirac understood and developed quantum mechanics, I would like to understand what were they reading during that time, what were their thoughts. I like to search for things, what were their uh, discussions like in conferences, what were their views according to that. And then I try to understand like what was the problem in classical mechanics, and then why was quantum mechanics built. So it's kind of a story that I try to build in my mind. So I start with Newton or even before and try to understand what was the problem and that led to this. This was not working and hence this, and this was not working and hence this. And this is the way I like approach physics. So it kind of helps you to understand like like if it kind of helps you and it prohibits you to make amateur theories like I've solved this problem, I've solved this, I have done this, I've done this. Because if you read how physics is done and how it was done earlier in times, it gives you an idea that your amateur ways of tackling and looking at problems are not good. So you should read more, solve more problems, develop a lot of mathematics, and understand the pains and the struggles behind the beautiful theories that we have right now. So that is kind of my approach. So earlier I was very hasty, and right now I'm a bit more patient. I approach problems and new things in a very critical manner and slow manner, patiently. That is what my view and for physics has changed. This is kind of the thing.
Okay.
Just to confirm, what was the aim of the whole talk?
I don't know. It was an interactive session. Yes.
No, I was just trying to make a joke.
Yeah, I know that.
Sorry.
Go ahead, go ahead. You have some question, something? Or there are people in line? I'm sorry.
There are the people in line.
Yeah, go ahead.
Yeah, and anyway, it is really nice to talk to Madhur Bhaiya anytime. So yeah. Okay. So next question is by Rita. Rita, if you can unmute yourself, please.
Hi, Bhaiya, am I audible?
Yeah, you are.
Okay, actually, I had a small question, sort of vague, but per se, there's a student who is deeply interested in physics and has a background in electronics and computer science, sort of like an engineering background, because as you would know, IISER Bhopal also offers BS in engineering science. So later on, if that person wants to study physics, say experimental or computational, what scope do you see, and what do you think would be the extra effort required to put?
See the extra. Okay, are you done with the question?
Yes,
Yeah.
Bhaiya.
So the extra efforts that you'd require is to understand the basic concepts first of all. The core courses that we all talk about. There are four of them: classical mechanics, electromagnetism, and electrodynamics, quantum mechanics, and statistical mechanics. If you understand these courses, you are good to go in in experimental and computational. And after that, when you decide a specific field, in for example in experimental, like that you want to study Raman spectroscopy, then you'll have to take courses in condensed matter. So that is the extra effort that you're talking about. Regarding the scope, it all depends on that time. So it depends if moreover, it depends on how the work is progressing. If there is a problem in some kind of a theory and it has been going on for 40-50 years, then people are like more likely to go on to some other thing and start working on that. So scope is dependent on that. And apart from that, coming from any field to physics is not at all tough. It all depends on your motivation, if you're interested in studying, and if you understand the concepts well. If you have a background in engineering, you already know, you already have, I assume that you already have a problem solving mind. So that would not be tough. So it is very easy for you to come into physics. It's what just would might be challenging is the abstract concepts and the hypothesis that comes into play in the development of the fundamental pillars of physics that I just mentioned. So if you can understand those, then you can start reading papers and work with people.
Thank you, Bhaiya.
Sure.
Okay. Adarsh also has a question. Adarsh, if you can unmute yourself.
Yeah. I had this question. Can you shed some light if you have any idea that how can we pursue a career in observational astronomy, purely in the field of astronomy? Any
This
idea?
is a perfect question for Parth Nayak. Like just like he works in this directly. So I'll just wait for him to write the answer. He has issues with his mic, but so yeah, he'll write the answer if he's there. Parth is here. Oh no, Parth is not here.
Anyway, I guess this would
Like
be.
I'll get this question answered by Parth, and I'll send it to you.
Yeah, okay.
Maybe.
Yeah, you can directly talk to him in any case.
Yeah, and you can also use the physics discussion forum which has been created for this as well. If
Yeah,
you
and other questions,
Okay.
Chakradhar is also here with us, so you can ask to like you if you have any other computational and condensed matter questions and quantum information questions, you can talk to him. He can answer.
Yep. All right.
Okay, Bhaiya.
Sure.
There are no more questions in the chat.
Like probably
Bhaiya, could you just tell?
Chakri was reading. If nobody's saying Chakri, would you like to say something?
Hello,
Like you heard some questions on experimental and computational. If you want to
hello.
add something.
Hello.
Hello.
Hello, Madhur. Can you hear me?
Yeah. Yes. Yeah. Yeah. Yeah.
I
I
think
can hear you, Chakri.
yeah, I think you answered them pretty well. No need
But
for
like I
trying
don't
to.
know a lot of stuff in your field.
Yeah, maybe we can. I mean, if there are any
Sure.
particular
Like,
questions, I can answer them.
Sure. Cool. Thank you. Yeah. Yes, you can speak.
So could you just tell the name of the blogger you followed for GRE?
Yeah, I'll send it to you.
Yeah.
I think it's Shriya something. I don't remember the name for it, but I'll send it to you. I think I sent it to Sarvesh. I don't remember, but I'll send it to you. Yeah, you
Okay,
need good
and
scores.
yeah, thank you.
Go on. Yash was saying something, I think.
No, I'm done. Thank you.
Okay, cool.
Okay. Shashank has a question. Shashank.
So, Bhaiya, suppose that you are working on something at your PhD level, and so is it that what you work at your PhD level becomes the work of your whole career, or at some point in the future you can switch? Like if you are interested in something else, so you can start working on that, and but it is not related to your PhD or previous thesis work. So, is it possible, or is it that
Yeah,
one?
yeah, you go on. Sorry.
Or is it that once you start walking on one path, you cannot take a turn or something?
It depends on if you can like convince the people who grant you money for that. So I more or less it depends on that. I think so. And if you have a good understanding, solid foundation on the field that you are choosing as a new path, I think you can work on it. There's nobody stopping you. But if you like, if you do not get grants, and if you get grant, for example, I'm working string theory, I suddenly want to go into condensed matter, and if I can convince the people at condensed matter, the people who are giving grants for that, that I'll be able to do like add substantial to the field, then I'll be good to go. But if I cannot, then I'll have to like like generate funds.
So, Bhaiya, are the theoretical people who are working in physics even they need to depend heavily on grants? Because one of the initial chats that I had with you, you said that all we need is pen and paper.
Yeah,
So,
that is true, but you need some money to give it to your PhD and your postdocs and the master students and the internship students that come.
okay, so
And you need money to go to conferences and all those things. So yeah, we need pen and paper. Yeah, we do not need machines. I do agree. But the thing is, like there are some computational things that we have to do. First of all, one, so you need computing capabilities, and apart from that, you need money to travel.
okay, so suppose that I want to change my path and I don't get the grant, okay, or I'm not able to convince the grant committee, but still I'm hell bent to change my path. So now talking of funds and traveling and computation, if I can arrange for it myself, then can
Mhm.
I take the turn?
Yeah, sure.
Okay.
Yeah, you will be there. If you are in a research institute, then it won't be a problem. I don't think so. But if you're there at a university, you'll have to talk to the. I cannot tell you right now. I've not done
Okay.
that. I'm
Okay.
sorry.
Thank you.
Yeah,
Thank you.
that is very hypothetical. Sorry. Yeah.
Waiting for more questions. If there are none, then it's already 6. Uh, it has been a 1 hour long session already. Okay, Devang has a question.
How do you approach problem solving? I cannot tell you. It depends on the problem, Devang. Like, how do you approach problem is a good question. How do you approach a problem solving? How do I tell you? I'm sorry. I don't understand that question. Could you please elaborate on that question, Devang? That is too vague. So Devang is asking, how do you approach problem solving and how do you approach a tough problem? I guess it depends on the type of problem. But in any case, I avoid numbers because I'm not good at numbers. I love variables. So this is one thing that I can tell you. I assign a variable to everything. Okay, but Rita, your mic was okay, right? Okay, with reference to DRE physics facility. So GRE physics is perfectly fine if you're done with your courses good in your masters at ISA Bhopal. It is a very easy paper. So you can do that. You just have to solve questions, be good at solving questions, and it's not at all difficult. How long did I take to prepare it? I did not prepare for it. Genuinely, I'm saying. I just went there. I like in the last two, like I had the exam on 26th of October. I gave two exams on 24th of October and one on 23rd. And 25th I was traveling, so I did not prepare. And I gave the exam, and it went pretty well.
Okay. I guess for Devang's question, like for example, you asked the question a few days ago in our chat, and you mentioned that this question was there in your PhD session as well.
You shouldn't have told that. Okay, go on now.
That's okay. But yeah,
Mhm.
how did you approach that question? Like, for just to set an example.
So, but no, I don't think so. Everybody knows that question, so that is like kind of vague for many of the people here.
Yeah, I think we haven't posted that question on the group.
Yeah, so at least you pose the question, then we can talk about that.
Okay, I was
Till then, Gaurav has a question.
yeah.
Hello, Aya. So can
Hi.
you please elaborate on the process of getting internship, like outside the country, and what are the process for getting grants and all?
Okay, so the thing is, like I went for the U trip that was in Japan. So they have a very simple procedure. You don't have to do any other thing. So what you have to give is your CV, your scores, your recommendations, and you have to fill the form. That's it. And you have to give a personal statement. I forgot about that. So in personal statement, you have to answer three questions. One, what are the skills that you have, and that would be helpful for doing a project at their place. Second, why should we choose you? And third, it was a very simple question. Are you trying? Uh, are you? What was the question? Are you That was like, do you want to do a master's at their place, that institute? So if you want, I can share you my personal statements that I gave for the internships, and just don't copy that. And you can have a look and understand like how to write personal statements. And that was it. And in DAD, probably the similar. So DAD process is a different process. So there you have to apply to a professor. You have to talk to a professor, and after talking to a professor, if he accepts you and is like without anything, you'll have to if he accepts if he accepts to host you as a internship student, then you apply for the DAD-wise internship, the scholarship. And if you get the scholarship, the DAD-wise, the DAD or the German embassy gives you the money to work with the professor. The professor has no relation to the DAD people. But at U-Trip or the Japan thing, everything was done by the University of Tokyo. The professors were there, and the money and the funding was also given by the University of Tokyo. At DAD, it was a different affair. And but the DAD affair, the DAD thing is the reality. You have to talk to the people and generate funds from different entities. So you have to like it all depends on what institution are you looking at, and there details to forms to fill. You just fill those forms. If there are interviews, you have to give that. If there are some standardized tests that you have to give, and you just complete those. And the most important thing in your profile that you send would be your CV. It would be your GRE scores and standardized test scores. Would be your grade reports, the courses that you take. But the most important of them would be the statement of purpose, like why do you want to pursue science or physics in general. So on science in general, why do you want to pursue physics or science in general? So you have to answer that and convince them that you're a good candidate, and that's it. What funding they give? What are you talking, which funding are you talking about? So the DART scholarship, it is just DART WISE scholarship, WISE, working internships in science and engineering. You can search on it. And for the second year, I went to Japan. That was U-Trip, UTRIP, University of Tokyo Research Internship Program. You can read about it as well. And there's another thing called CHARP. There are many internships. That is, I think, the career council, the department that we have, the council that we have, they can tell you about more internships.
Okay. We can have one more question if there is any, and then we can wrap it up because it's already 6:16 now.
Sure.
So if anyone has a question, then if not, then okay. Yeah, I guess.
Okay, so Swagata has asked, it would be very informative if you would elaborate on writing a statement of purpose. So that is a tough question to answer. Um, So I started with explaining why I started in physics, why I landed up in physics, why I interested in physics. So that was the first part. And the second part I did was I explained about my internships and I what gained from them and how my skills developed. And the third part was what are the courses that I took and what I understood and how well I am with them, explaining that. And the fourth part was what research I'm doing and what I'm interested in. Fifth part was how the university that I'm applying to in the statement of purpose is good for me, and how all the first, second, third, and fourth parts relate to that fifth part. How is that university giving me everything? And sixth part was like thanking the committee, the 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 graduate committee who is looking at my statement of purpose. These were the six parts that I generally followed while writing my statement of purpose, and I wrote that. I like just answer those things, those six things.
Okay. So I guess that should be it for today. Uh, like it's 6:18 now. So yeah, don't want to make it too long. If there are any more questions, then you can use the Physics Club discussion forum for that, the WhatsApp group that has been made. And yeah, or just contact Madhur Bhaiya. I guess Madhur Bhaiya can tell you when to contact him.
Yeah, Sundays after 5, anytime
Okay.
after 5.
Okay, cool. Thank you for being such a nice audience. It has been really smooth. And
So should I give my contact details in the chat right now, or you'll provide it somewhere?
if you are comfortable with it, then yeah, sure, go ahead.
I am comfortable with any.
Yeah, okay, then sure.
Okay, he's asked me. Yeah. Okay, so I'll just.
Okay.
And there are other people. They were here. Like there is Chakri here, Chakradhar. There is Aritra Mishra, and there was Parth Nayak. You can talk to those people as well. They are very good in their respective fields, and they'll be very helpful. It'll be very helpful for you to talk to them.
Yeah, and in general, if you guys need any contact details of these guys, you can anytime come to me or Amay. I'm sure we'll be able to manage something regarding
Yeah.
that.
And you can always, like, we'll be using our email IDs, the ISAB email IDs, at least for a year right now, I think so. So you can email us. Like, there is Chakradhar, there is Aditra Mishra, there is Parth Nayak. You can talk to us.
Okay. So, are there any more uh, doubts regarding contacts? I guess.
Questions.
Okay, so I guess that should be it for today. Thank you, Madhur Bhaiya. And
Thank you.
yeah,
Welcome. My pleasure.
yeah, and yeah, stay tuned for more meets coming up in the next upcoming month or so. And then, yeah, please do provide your feedback regarding this, and any sort of suggestions will also be welcome about how we can improve on the online meets. So, yeah, I guess that should be it.
Thank you, everyone.